Let's try solving this question on gravitation. Two masses, 1.2 kilograms and 60 kilograms, are 120 centimeters apart from their centers. Calculate A, the gravitational force between them, and the acceleration of the motion of the smaller mass. Take universal gravitational constant to be 6.6 times 10 to the power negative 11 Newton meter square per kilogram square. So we have two masses, maybe a smaller mass and a bigger mass. And this mass is 1.2 kilograms and this is 60 kilograms. That is what the question is telling us. Then from their centers, the distance from their centers is 120 centimeters. So we have to find the gravitational force between these two masses. And after that, we will find the acceleration of motion of the smaller mass. So this is a visual representation of the question. Now let's move straight up and find or solve the question. So first of all, let's write out all the important parameters that we have from the question. So what exactly have we been given in the question? So this is something we should always do if we have a question of this nature. So we first have the mass, the two masses. So we represent the first mass or the mass of the smaller object using small m, m1. So m1, which represents the mass of the smaller object, is 1.2 kilograms. And m2, which represents the mass of the bigger object, should be 60 kilograms. We have this from the question. Then we also have the distance between the two objects. So for the distance, we represent it by using r. When this 120 centimeters is converted to meters, we have it to be 1.2 meters. And it is important for us to convert it to meters because the universal gravitational constant is the unit of it is Newton meter square per kilogram square. So we actually need the distance to be in meters. So these are actually the parameters that we have been given from the question. Now let's answer the first part of our question, which is what is the gravitational force between them? And the formula we'll be using will be F equal capital G M1 M2 divided by R squared. This formula is known as Newton's law of gravitation. That's how this formula is called, Newton's law of gravitation. According to this formula, which is Newton's law of gravitation, he is trying to just tell us that two objects that are in space, actually the force between them is basically the product of their masses divided by the square of the distance between the two objects. That is what the Newton's law of gravitation is trying to tell us. So this is the force we are trying to find. We already have our G, we have our M1, M2, and R squared. So now let's just move on by replacing all our symbols or our alphabets here with the appropriate figures. So remember the G here is this value is 6.6 times 10 to the power negative 11. So let's put it there. G is 6.6 times 10 to the power negative 11. We will not write the unit. That will be too lengthy. Times M1. M1 is 1.2 kilogram times M2. That will be 60 kilograms divided by R squared. R squared is 1.2. So we have 1.2 R squared. If you punch this figure into your calculator, you are going to get the force between the two objects to be 3.335 times 10 to the power negative 9 Newton. We know that the unit for force is Newton, so just input the Newtons over there. And actually, if you have the time to write the units attached and do your cancellations, you realize that you'll be left with only Newton. So this is the first part of our question, which is the force between them. So we'll write this somewhere and continue with solving the second part of our question, which is the acceleration of motion of the smaller object. So in order to solve the second part of our question, we just move straight up to using the formula for force. Generally, we know force is equal to mass times acceleration. Mass times acceleration, that's the general formula for force. And then we've already solved for the force, gravitational force between the two masses. And the gravitational force between the two masses is common to both the smaller mass and the bigger mass. So the force is what we have in the A part of the question. But the mass in this scenario is the mass of the smaller object. So the force is equal to the mass of the smaller object. If you remember correctly, the mass of the smaller object is m1 times the acceleration that we have here. X is the acceleration we are looking for. Let's represent it using A. So from this formula, we can actually deduce that A is equal to force divided by m1. And the force is 3.335. 3.335 times 10 to the power negative 9 divided by the mass. The mass is actually 1.2. That's the mass of the smaller object. If you key this into your calculator, you're actually going to get the acceleration of motion of the smaller object to be 2.78. 2.78 times 10 to the power negative 9 meters per second square. So this is how to solve for the B. Although we have not been asked to find the acceleration of motion of the bigger object, the formula is going to be the same if we're asked to do that, because you are going to use the same force. So in place of the M1, you will just use M2, which is 60 kilograms. So if you put 60 kilograms in place of the 1.2 kilograms, that will give you the force, or that will give you the acceleration of motion of the bigger object. So this is how to solve for the question, and thank you very much for joining us.